This is Lala sir giving the lecture of chemistry on the topic structure of atom. Now, these are few points which we are going to revise for you before we start this atom concept. See, J.J. Thomson in the year 1897 investigated the cathode rays, which are 1837 times lighter than the hydrogen atom. That means previously it was thought that hydrogen atom was the smallest, but then they discovered after 1897 that there are still some particles which are lighter than hydrogen. Rutherford in 1911 discovered proton by bombarding a particle on nitrogen. Then James Chadwick in 1932 discovered neutron. The composition of an atom is represented by A, Z, Ax below Z. A is the atomic mass, Z is the atomic number. So it is represented by A, Z, X. A is atomic mass, and Z is the atomic number. Z is atomic number. Z is the atomic number. Then we discuss about isotopes. Now, some elements have got many isotopes and some don't have an isotopes. Isotopes, what are isotopes? Isotopes are the atoms of the same element with the same atomic number but different atomic mass number. Example, carbon 12, C12 6, C13 6 carbon again, C14 6. So these are all isotopes. Then we come to the concept of isobars. What are isobars? Isobars are the atoms of the different elements with the same atomic mass number but different atomic number. For example, Ar 40 80, potassium 40 upon 90, calcium 40 upon 20. So Ar is the argon. So we are having this isobars. Then the concept of isotopes. What are isotopes? Isotopes are atoms of different elements having the same number of neutrons in the nuclei. As we all know, there is a nucleus inside, so it is containing neutrons, then comes protons and then electrons. Okay, isotopes are the atoms of the different elements having the same number of neutrons in their nuclei. For example, B having 11 5, carbon 12 6. So according to J.J. Thomson, a scientist, atom is a sphere of uniform positive charge into which negative charge electrons are embedded. They are moving around the circles. They are embedded. Then we come to the concept of Rutherford. According to Rutherford, an atom consists of positively charged nucleus which is surrounded by the system of electrons. They are held together by electrostatic force of attraction. He failed to explain the stability of the electron in the line spectra of an atom. Considering the light as dual nature. What do I mean by dual nature? Dual nature means it is either electron along with the particles. So it is called dual nature. The concept of electromagnetic radiation was introduced. The following are the characteristics of electromagnetic wave like wavelength, frequency, wave number, amplitude. Now the particles of the electromagnetic radiations, energy of one quantum of radiation is proportional to its frequency V. E is equal to hV. What is E? E is equal to hV. This is the concept of formula on which you may get numericals. Now what is E? E is equal to hV. So H is the Planck's constant, which value is fixed 6.626 into 10 raised to minus 34 Jn. Now when I study hydrogen spectra, it reveals that in the line spectra, V is equal to 109667 upon 1 upon 91 square minus 1 upon 2 square centimeter minus 1, or V lambda V vector is equal to RH 1 upon n1 square minus 1 upon n2 square. So we are removing the 1 upon n1 from the bracket. Now RH is Rydberg constant for hydrogen. When n1 is equal to 1, n2 will be equal to 2, 3, 4. That is layman UV. When n1 is equal to 2, n2 will be equal to 3, 4. That is Balmer visible. When n1 is equal to 3, n2 will be equal to 4 and 5. That is Paschen IR. When n1 is equal to 4, n2 is equal to 5 and 6. That is bracket IR. Now n1 is equal to 5, n2 will be equal to 6 and 7. That is P fund IR. According to Bohr's model of atom consists of nucleus of the center, and the electronics are revolving around the nucleus in differential, and the orbits which are quantized. Therefore, delta E is equal to HV, MVR is equal to NH upon 2 pi, when Rn is equal to a to the power 0 into n square. Now what is a to the power 0? It is 52.9 pm picometer, or A0 is equal to 0.529 A degrees. That means radius of the first stationary orbit is 52.9 pm. Now with another formula, EV is equal to minus RH upon 1 n square. RH is equal to Rydberg constant for hydrogen, and its value is 2.18 into 10 raised to minus 18 J. Therefore, E1 will be equal to minus 2.18 into 10 raised to minus 18 J. E2 will be equal to 0.545 into 10 raised to minus 18 J. For hydrogen-like spices, E1 is equal to minus 2.18 into 10 raised to minus 18. That is Z square upon N square J. Therefore, Rn is equal to 52.9 N square upon Z Pm. Therefore, according to de Broglie equation, lambda is equal to H upon P is equal to H upon Mv. According to Heisenberg uncertainty principle, delta X is equal to delta Px is greater than or equal to H upon 4 pi, or delta X is equal to, instead of P we are writing Mvx is greater than or equal to H upon 4 pi. Delta X into delta Vx is greater than equal to H upon 4 pi m, where delta X is uncertainty with respect to the position, and delta Px or delta Vx is uncertainty with respect to momentum. According to quantum mechanical model, considering the electron the dual nature. When I mean electron as a dual nature, it sometimes behave as a wave and sometimes behave as a particle. That is why it is dual nature. And solving the Schrödinger wave equation, quantum numbers are introduced. Schrödinger wave equation says He greater than lambda v, where lambda v is equal to wave function. Lambda v square gives probability of finding the electron along the nucleus in the orbit. Now we discuss a little bit about Paul expulsion principle. An orbital can accommodate maximum 2 electrons with opposite spin. Okay, we will have only 2 electrons and they both will have opposite spin. Means if one electron is moving clockwise, the other electron will move in anti-clockwise. Now we got Isobars principle, which says that electron enters into various orbitals, always in order of increasing energy or increasing n plus L values. If n plus 1 value are smaller, then the lower n value will be filled first. Hunt's rule of maximum multiplicity. That means pairing of electrons in the orbitals belonging to same subshell does not occur unless each orbital belonging to the subshell has got one electron in each. That means that electron will be available to go to the other orbit. Electronic configuration of the is the distribution of electrons in the orbital of the atom. Now, for example, copper and chromium. Copper and chromium has the electronic configuration of Ar3d10 4s1 and Ar18 3d5 4s1. Because half-filled and completely filled orbitals are more stable, isoelectronic spices have same number of electrons. It is a common question in the 12th standard also. Write down the electronic configuration of copper and chromium. Okay, so this was the we were discussing. Now we have got a concept of quantum numbers. What are principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. In principal quantum number, we identify the shell. The shells are represented by M, L, K, L, M, N. It is denoted by N. Therefore, number of allowed particles or therefore number of allowed orbitals is equal to N square. Azimuthal, it indicates the number of subshell. The number of subshell is equal to N. The subshells are represented by S, P, D, F. The value of L range from 0 to N minus 1. Magnetic orbital. It signifies the spatial orientation of the orbital in a given subshell. It is denoted by M1. It gives the total number of orbitals in a consumed shell. That means that shell is completely having a complete number of electrons. The allowed value is ML is equal to 2L plus 1. These formulas are very important for you to remember, because all the numericals will be based on these concepts only. Spin. It specifies spin state of electron. It is denoted by Ma. It imparts the spin of the angular momentum. The two spin states are clockwise and anti-clockwise spin. Electrons have opposite sign. So this much is the portion which we are going to discuss in detail, step by step, and you will have to remember all these concepts, because most of the numericals even in 11th and in 12th are also based on these concepts. At least one numerical comes in the 12th standard also. Okay, so we are discussing what do I mean by the properties of the subatomic particles. Electron, symbol E, absolute charge per C is minus 1.6022 into 10 raised to minus 19. Relative charge will be minus 1. Symbol for the charge is minus E. Mass per kg will be 9.10938 into 10 raised to minus 31. That is mass per U, which will be 0.0051. Approximate mass upon U ratio will be 0U. Then we come to proton. The symbol will be P. Absolute charge will be 1 plus 1.6022 into 10 raised to minus 19. Relative charge will be plus 1. Symbol charge will be plus E. Mass per kg will be 1.6726 into 10 raised to minus 27, which is equal to 1.00727 or 1U. Neutron N. Absolute charge per C will be 0. Relative charge will be 0. Symbol for the charge is not there. Mass per kg will be 9.010938 into 10 raised to minus 31. Therefore, 1.67493 into 10 raised to minus 27 will be for neutron. Therefore, mass per unit will be 1.00867, which is equal to 1 U. Now, how was the electron discovered? We will show you this. In the year 1897, J.J. Thomson investigated and found that Cathode rays are stream of very small negatively charged particles. They are 1837 times lighter than the hydrogen atom. They are present in all atoms and later they were named as electrons. See, I am showing you the diagram. This diagram is a cathode ray tube. This is a cathode ray tube. We insert cathode rays at the end and anode is at A, plus mark minus charge. Then we got two silver parts which will, when we pass cathode rays, the original part if it's on the screen, that original part and deflected part. So this gave us a complete information that electrons exist, and this is the way we discover electrons. Now we come to know proton. A proton is defined as subatomic particle which has a mass of 1.00727 AeMu and a charge of +1 elementary charge unit. It has 1 unit mass of 1 positive charge. Discovery of proton. In the year 1911, elements Rutherford found an experiment of scattering of alpha particles by thin gold foil. See the figure 4.2. See this figure. See the figure 4.2. See the figure we are discussing. In the year 1911, Ernest Rutherford found in an experiment of scattering alpha particles by thin gold foil. See figure 4.2 that a few alpha particles bounce back he inferred in the presence of massive and positively charged nucleus inside of the atom. Following the discovery of nucleus in an atom, Rutherford found in 1919 the fast-moving alpha particle transmuted nitrogen into oxygen with the simultaneous liberation of hydrogen. That means nitrogen 14/7 plus alpha 4/2 will give us 17.80 plus 11H, or 14/7N will give us helium 4/2 minus 17/8O plus 1/1H. He further showed that other elements could be transmuted, but hydrogen was always emitted. On the Rutherford proposed that hydrogen nucleus must be contained inside the nuclei of all elements. Hence the hydrogen nuclei was renamed as proton. So now your concept of proton should be clear. This is a source of alpha particles. Alpha particles are bombarded on lead plate, which is further covered by a gold foil, photographic plate and scintillation. Okay. Then we found that neutron was also discovered. The neutron is what? That in a plutonium source we are bombarding alpha particle on beryllium and paraffin. Neutron is coming and further proton was emitted. In theoretical requirements of the existence of neutral particles in atomic nucleus was predicted by Rutherford in 1920. Rutherford could not account for the disparity into atomic number and atomic mass of an element. In the year 1932, James Chadwick measured the velocity of a proton knocked out from paraffin by unidentified radiation from beryllium. Beryllium is a metal. See figure 4.3. That he determined the mass of the particle of the unidentified neutral radiation which come out to be almost same as that of a proton. He named the particle as neutron, which was predicted by Rutherford earlier. Therefore, Neutron can be defined as a subatomic particle which has a mass almost equal to that of a proton and has no charge. So now I want to discuss with you what is the difference between proton, neutron and electron. Now when a parameter is charge, the proton carries unit positive charge plus 1.6022 into 10 raised to minus 19. Neutron no charge, electron unit negative minus 1.6022 into 10 raised to minus 19. Mass 1.0078 mu is equal to 1 mu. 1.0086 AMU is equal to 1 AMU for neutron, and for electron we have got 0.0055 is equal to 0 AMU. Now we have the denotation. Proton will be 1H1. That because hydrogen will be there inside, which is named as proton 1H1. Neutron 0N1. Electron minus 1E0. Location. Nucleus will be in proton. Neutron will be in the nucleus. Proton will be also in the nucleus. And electron will be extra nuclear region. Effect in the magnetic field and electric field. Deflected towards the negative plate, remains undeflected in electric and magnetic fields. Deflected towards positive plate. Discovered by Rutherford is proton. Rutherford 1911, neutron Chadwick 1932, electron J.J. Thomson 1897. Approximately mass per U, 1 U for proton, for neutron 1 U, and for electron 0. So we have come to the process of neutron, proton and electron. Now the next step which I am going to discuss with you is atomic number and atomic mass number. If the atomic number is denoted by Z, atomic number of an element is equal to the number of unit positive charges or number of proton present in nucleus of an atom, of an element. Since an atom as a whole is neutral, it possesses an equal number of electrons in the extra nuclear region. Therefore, Z is equal to number of protons is equal to number of electrons. In that complete shell, number of protons will always be equal to number of electrons. That means Z will be always be equal to number of protons, which will be also equal to number of electrons. That this atomic represents, now atomic number of any element will be represented by number of protons in a nucleus, number of unit positive charges, number of electrons in neutral atom. Explain example. Boron. Boron occupies 5th position in the periodic table and has atomic number 5. This implies that it has a nucleus containing 5 protons plus 5 and 5 extra nuclear electrons. Mass number. The elementary particles present in nucleus, protons and neutrons of an atom are referred to as nucleons. The mass number A of an atom is equal to the total number of nucleons in the nucleus of an atom, or the sum of protons Z and neutrons N in the nucleus of an atom is called mass number A of the atom. It is always a whole number. The mass number A is equal to number of protons Z plus number of neutrons N. Therefore, number of neutrons N will be equal to mass number A minus number of protons Z. N is equal to A minus Z. For example, atomic number of an sodium is 11 and the mass number is 23. Z is equal to 11 and A is equal to 23. Hence, the number of neutrons in the sodium will be A minus Z, that is 23 minus 11 is equal to 12. Now the general notation that is used to represent the mass number and the atomic number of a given atom is A upon ZX, where X is the symbol of an element, A is the mass number, and Z is the atomic number. What is nucleoside? The composition of any atom of a nucleus is represented by the element X and the atomic number A as a superscript on the left and the atomic number Z as the subscript. The unit composition will be X to the power A, and below Z is also called nuclide. So I discussed with you the concept of nuclide also. Now we come to the information. We have to complete the information of following isotopes. Now for example, carbon 14, substance is carbon and it is 14. Therefore its mass number will be 14. That means it will have equal number of electrons and protons. That should be equal. That means proton will be 6, neutrons will be 8 and electrons will be 6. Lead 208. Therefore the mass number will be 208. It will have 82 protons and 126 neutrons and electrons will be 82. Chlorine 35. Mass number of chlorine will be 35. Protons will be 17. Neutrons will be 18 and electrons will be 17. That is why we get 35. Now uranium. Uranium is 238. 238, 92 is the proton, neutrons is 146 and electron is 92. Oxygen is 18. Mass number 18, proton 8, neutrons 10 and electrons 8. Radium, mass number is 223, protons is 88, neutron is 135 and electron is 88. Electron is 88. So we have to discuss, this is a way we have to calculate number of electrons and number of protons. Now we have to find out, for example, if an element has a X has a mass number 11 and it has a 6 neutron, then it will be represented by X 11 upon 11 minus 5, that is 6. So now we are just going to discuss what are isotopes and what are isobars. Okay, so isotopes are atoms of same element having the same atomic number but different atomic mass. Again I will repeat, isotopes are the atoms of the same element having the same atomic number but different atomic mass number. Second, all isotopes of the elements have the same number of protons but different number of neutrons in their nuclei. All the isotopes of an element have the same position in the modern periodic table and the same chemical properties. So this is about isotopes and isobars and isotopes also I am going to discuss now. Isotopes of the hydrogen, plutonium is also called hydrogen, also called plutonium, deuterium and tritium. The formula of plutonium will be 1H1 and that of deuterium will be 2H1. It is also called D. Deuterium is heavy water. Heavy water we are importing it from USA and we are supplying to our Taloja plant for making electricity. Tritium, it is H3 upon 1 tritium. The mass number of plutonium will be 1. Number of protons will be 1, therefore number of neutrons will be 0. Deuterium, the mass number will be 2, number of protons will be 1 and number of neutrons will be 1. Tritium, mass number is 3, number of protons is 1 and number of neutrons are 2. So as per the isotope formula, isotopes of oxygen. Now, isotope of formula of oxygen is O16 by 8, O17 by 8 and O18 by 8. These are 3 isotopes of oxygen. Therefore, mass number of oxygen O16 by 8 will be 16, number of protons will be 8 and number of neutrons will be 8. O17, mass number will be 17, number of protons will be 8 and number of neutrons will be 9. Then O18, mass number will be 18, number of protons will be 8, and number of neutrons will be 10. Isotopes of some common elements are carbon 12/12 6, carbon 13/6, and carbon 14/6. Nitrogen N 14/7 and 15/7. Uranium is a radioactive element which India is importing till now for all our activities of radioactivities. Uranium will be 233/92, U is 235/92, and another uranium is 238/92. So we got 233, 235 uranium and 238 uranium. Sulfur S is 32/16. One we got one isotope. Another isotope is 33s/16. Another isotope is 34s/16 and 36s/16.